Okay guys, so this is all about DynamoDB. We are going to discuss, we've already discussed few points, few little points, but I'm going to repeat them again in a quick review. The DynamoDB is nothing but it's a NoSQL database. When compared to RDS, we have an advantage in this that DynamoDB offers push button scaling, which is nothing but when you wanted to increase your capacity, your database capacity, maybe in terms of memory, you can just do it on the fly without bringing it down, like push button scaling. That's what. And it is the best suitable are suggested to choose when scaling is required and without bringing your database down. So that is what. And when we have gone through the few points yesterday, it's like it is very fast and flexible NoSQL database service for all the applications that need consistent single digit millisecond latency. That is what the best thing about DynamoDB. So we can just use this for the applications that needs a very less latency. Guys, you able to hear me in the C screen, right? Everybody? Yeah, that's what. So that is a point, and it is it is also performs very well with the applications that can fit into mobile, the gaming, and many other things. So that is the best part about it, and its pricing is also simple and so cheap. The only thing is when it comes to pricing, it's DynamoDB expensive for writes because it charges the same amount, like that's $0.0065 per 10 units, but whereas read it charges the same amount for 50 units. So that's how we say DynamoDB is expensive when compared to for writes, but cheaper for reads. So that is the point we've just seen. And what else? Let's go and create DynamoDB table today. So we have seen how to create an RDS instance and RDS database. Then we've also seen how to connect that. Okay. So let's see creating a DynamoDB table here. But do you remember initially, very beginning, we discussed something about the differences, how what way this RDS and DynamoDB will have. We have discussed something like RDS instances will always have tables. Tables will have rows. You remember, guys? Hmm? Yeah. So DynamoDB. Now we are going to see like the differences are what we have seen. RDS contains databases. Databases contains tables. Tables contains rows and rows to fields. But whereas NoSQL, that's at DynamoDB, of course this do have a database. The database contains collections. The collections will have documents and the documents will have key value pairs. So that's what we're going to see. For this, we don't require, we probably don't require any instance. We can directly go access this and see what we are going to do that today now. So when you are going to create a table, a DynamoDB table for the first time, your screen appears this way because whatever I have created, I deleted successfully, so it looks very fresh for me every time I do. And I suggest you guys to do the same so that you become hands-on by doing many a number of times whenever you wanted to do things. So now the very first thing is you have to provide a key, the table name. So this is, I'll just say what my something like that I've given. And primary key, it's like you select the string, a binary, a number. Don't worry, you'll understand what it is. It will be a string. Okay. Or else, yeah, string. That's nothing but you provide here as a number. This will work out while we create the table, the primary key. So that's what we are just mentioning here. It starts with that string, and the string is what? A number. You can just, the students who know computers a little can understand string, binary, and numbers. So what do we do? Better we take a number here. So here I'll just take nothing. So string is nothing but anything, any alphabet, anything you wanted to mention, you can just go with binary, some digits, 010101, something like that, and number, you can just take anything. So that's all. I'm not, see the table default settings provides, okay, just go through this. DynamoDB is a schema-less database that only requires a table name and primary key. The table's primary key is made up of one or two attributes that uniquely identify items. So that uniquely identify with that, the tables are differentiated. Okay, this table belongs to that, or this table is meant for this, or created for this, something like that. It is just created. Partition of data and sort data within each partition.
Sir,
That's what. Somebody speaking?
sir, yeah, sir. Sai.
So yes, I tell me please.
So you said RDS has tables, rows, and fields, but DynamoDB has collections, documents, and key pairs.
Yeah.
But in DynamoDB here we're discussing about tables.
We are tables. We are talking like that, but it will be something different. Once after we are done with this, while creating a table, you will see the string. I think I've shown you guys how the structure will be. It's like a code we write.
Yeah, code. Yeah, we write it code. Yeah,
You
I
remember
remember it. Sir.
we have discussed about
Yeah.
database initially the first day
Uh,
in a notepad app.
yeah, address. Yeah, the code is about address. Yeah.
Yeah. So that will be it is. You will just see now. In a moment, we will just go create that. You will understand. It's mentioned as table.
Okay. Sir.
The collection is nothing but when we wanted to compare, collections are nothing but table.
Okay.
Okay. To
Okay.
understand
Sir.
in an easy way without having any confusion, the collection is nothing but the table here when we compare. In terms of RDS, the table means here it is collection, and document is nothing but rows. Key value pairs are nothing but fields. Okay. It looks like people get little confused or may not have or find it difficulty to write something in terms of a code, a database in terms of a code. Taking codes and double quotes and then brackets and all that will be a little difficult for people. So we convert it into a normal table structure for our easy purpose. That I'll show you after once we are done with this database, and then when we're going to create a table in this, we can directly create a table here. That's nothing but a collection. I'll show you that. Okay. So default settings provide the fastest way to get started with your table. Okay, you can modify these default settings now or after your table has been created. Let's see what are those. Not, no secondary index, nothing like that. So I'm not. I once checked that there are a few more things we have to set. Like we can set if we wanted, or we can also do that. Okay, later on whenever we wanted. And you see this read write capacity, this is what is important. So the secondary index, you wanted any secondary index like this, you can just take here, it's up to you. And provisioned capacity, okay, the provisioned capacity is what? The read write capacity, read capacity units and write capacity units. Estimated cost is also mentioned over there. So let me just take it one. The cost has reduced. So the read, I'll just take 5 as it is. Right, I'll just make it 1. See the cost, it has reduced drastically. So you can just change your read and write capacity settings here if you want. You can increase, you can decrease, whatever you wanted you can do, and this can also be done after once the table is created. Okay, so let it be, let's like that. We'll just go and
Sir, if you don't mind, can you repeat once again what is read and what is write?
see. Database is what a database is something where we can store our data in an organization, in a structural way, I can say, right? So when we are using a database, we upload all of our data into that, and we wanted to access from somewhere. When we are trying to access somewhere, it's nothing but you are reading the data in the database. That makes sense?
Yes, sir.
Yes. And initially you wanted to store some data into that. The database is created, but when you create database, will it have will it contain entire data you wanted into that? Obviously not. We ourselves have to enter the data into that manually. So that is right. Okay. So writing the data into database initially charges you more, but we write only for once whatever the data it is. But accessing it, reading the data by people's users, clients out, may be possibly done more than any number of times than we write. Right? Does that make sense? Read and write capacity is nothing but read is nothing but accessing the data, write is nothing but loading the data into the database in simple terms.
Okay, sir. Got it.
So let's go create the database.
What is secondary index, sir?
This I'm just taking number, and the number default there take 1, 2, 3, 4, 5. If you want another one like primary key and the secondary key you wanted, you can just go with that. And let it be default for now 5, 5, since we are going to delete it soon after we are done with this. Okay, so that's all. Our table is created. It's getting created. Table is nothing but here collection only, but for our understanding purpose, we are comparing table is nothing but collection. So you see, the table is my DynamoDB, and the stream enabled. No, view type. No, all the details whatever we have mentioned. Primary partition keys 1, 2, 3, 4, 5. That's number. Table status it is active and all. Read and write capacity 5, 5 we have initially. Storage size in bytes it's 0. Item count 0, and with the region it's in Sydney. That's the URL or link provided or DNS name provided to this database. Okay. Now what we said, we can, as I said, go to items. Now this is where we have to create. Okay. Table is selected. We have to go into the table, and once table is selected, go to items. This is where we can create our table, which is nothing but you know, in terms of database, it is like a table, but don't worry, we are going to create it here. Now you see the 1, 2, 3, 4, 5, which we have initially taken is provided here. For what purpose this database is created? So that is the name initially we provide. Okay, and now we have to go create things here in this. Now I'm going to create items. Okay, and that items can be of different ways. Remember, okay, let this be completed. Once the collection is created, we'll see. The number, that's nothing but 1, 2, 3, 4, 5. Here the value. What's the value? Let's give 1 here, and I'll say append. What I'm going to append, I'll just say append string. Okay, the moment you say append, you'll have another item to be created, and the name is the string. What is this purpose? I'll just say it is the name. And what is the name? Name is John. I'll say something like that. Then I'll say one more number. I'll say what is it for age? Okay. I'll say here John's age is maybe 25, something like that. And you wanted to insert an item somewhere in between. Okay, rather you go up and you say insert. Insert will take you to go and insert one column above or one row above. So I'll say string. See, it has just taken you to insert an item one column above. If you wanted to insert somewhere in between this, then you have to click on this and then insert. You clear with that? So I'll say um, sex, which is male. So I have mentioned. Now the same thing you wanted to see in another way, the format. Okay, text format. You see the code. You got your things back side. This is what we have seen when we have discussed our databases for the first time. That will be in
Yes,
terms
sir.
of script and all. So here this is what, because people find it difficult to take something in quotes and write colons and all. If you go somewhere, if you miss something, a small thing, a comma or something, then that goes invalid. That won't work. That's the reason why for our convenient purpose, we ourselves have made it into the normal simplest way. Then go save. It will get saved. So John's age, that and all. Now let's go create another item. Let it be number 2. Okay. I'll say string name Mary. Then I'll say string again. Then
Then Amazon this or NoSQL has this kind of thing.
NoSQL. NoSQL has in Amazon NoSQL databases can be created this way.
Okay. Generally, when we write a script in only NoSQL, we write like this, or we should type everything.
We have to write a script, and then that script when executed it will create a database in actual databases in normal NoSQL databases. But in Amazon database, no DynamoDB, we create like this. It's easy
Oh,
because Amazon has provided some options for us here and this.
okay, so this option is only in Amazon,
Only,
NoSQL.
only in Amazon is exactly. And in real time, what we do is we don't create. I mean, like being an admin, we never create a database unless you support to a project wherein you are the owner and you yourself have to do everything from the scratch. Okay, maybe it is a startup company, or maybe the project is very new and you are the owner for that, or you are the in charge for that, and you have to build everything on your own. In that situation you have to create everything. But usually what happens, in an established project, the project which is already set and running, and when there is a request comes for a database creation, the database creation is not simply done, because that there will be some requirement. A user expects some sort of output from that, and for that we not only we, every organization will have database engineers separately hired for that. So what we initially do, at least what I did in my company, I have created as an instance. If it is an RDS, Usually we get many of the requests per RDS instance only because that is the only database mostly used, widely used across the globe. Okay, so relational database or SQL database or MySQL database. We initially create an instance with PHP and PHP MySQL installed in it. Then we provide the access to that instance to the SQL guy, the database guy. The full permissions are provided to them. So what they do, they just take the control of that instance, go create their database on their required way. So they'll have some parameters they need to set. Only then the script or the table a database created properly, and then the proper output based on client's requirement it will give us, it will give. And sometimes client directly coordinate, and it's not only that, it's not happen in win-win situation. Just like you asked me, I have created. What they usually does is they work around about it. Sometimes the users will have something in their mind and they ask for creating a database. But later on, when these people done with creating and they show the output, they may wanted some more changes. So they alter the code and then execute it again, and then finally once they are satisfied, they say, okay, this is the one we wanted, something like that. They say. So we don't have any idea because at least myself, I don't have much knowledge about database. The only thing I have learned I'm using in terms of AWS point of view, but not actually what a database. How do we create writing queries? We actually write queries in that. It's nothing but script to execute the database and to create the database and all to get a proper output. So all those things will be done at database guide. That is what initially we do. So if you are interested to learn database, learn it separately as a separate course. Oracle database or any database you wanted to learn, then you'll have a command on that because that's a huge course again, huge content to learn in that. And then you can just say, okay, I'm an AWS guy. I have an idea about AWS and database that will get you so many opportunities. If not, you can just normally go as a AWS cloud engineer. That will also help you. You can just play with all the other services. Clear? Then I'll say um, age, okay, number I'll take something like 52. And another one I'll just insert. What do we do this time? What else a person can have? String.
Status.
Oh yeah, marital status we can say. Let's say M status. Let's say no. Fine. So save. Now you see we have two different items created. One is John, he's male, and the other one is Mary, female. And Mary has one column extra, that's marital status, but whereas John doesn't have. So you wanted to search, you can always search with respect to your columns. How do you search? The table name scan. Okay, here you say filter, go to filter. With respect to marital status you wanted to search, okay, then you can just status, because there may be so many things, so many people, so many items added. Out of all that you wanted to check equals to, you can enter some value, then start search. Equals to no answer. See, you get only one. It's not, of course we have only two, so both of them are seen. But you have a number of items created, and in that you wanted to check who and all have not married, who and all have married. When you wanted to check all those things, this way you can just search. You wanted to search with age, you wanted to, I'll say, now this time I'll search with age. So I'll say number, age, which is less than or equals to, I'll say 24. It still give us Mary only. But if I say greater than or equals to, let's see what we'll get. John, right? So that makes sense, right? This is working. So we have created a database and we have, inserted or added items to that, created items to that, and we are able to find them. We are able to know the data. It's as simple as, it's so simple that you have created a database and then inserted data into that and you are finding it. You are just able to manage that data. So this is what the DynamoDB, NoDB, and matrices. These are the other columns we need to understand. This is just a, monitoring thing. What read capacities and all. This is what you can just see. It's like a monitoring thing. Detailed monitoring will always charge, so never ever select detailed monitoring. Alarms. There are two different alarms created by default. The basic alarm consumes read capacity which is greater than or equals to 4 or 5 minutes. Consume write capacity units which is greater than or equals to 4 per 5 minutes. We have mentioned 5, right? So that's why it is greater than or 4 equals to 5 minutes. Notify SNS topic, DynamoDB. The actions are created, but okay, you wanted to make them use, you wanted to create few more alarms, you can just go with that. And capacity, this is where you can change your capacity and save. See, without bringing our database down, we are trying to change things here. So that is the point. That is the best thing about, the database. Indexes, no indexes, access. This is another, security level thing. But what you need to know is this. When you wanted to increase or decrease its capacity, you can still do without bringing the database down. That is what I'm trying to tell you. Like, it is very, very important. You have to remember that when a normal database, an RDS instance, when you wanted to work with that, it must need to, brought down to increase its capacity. But whereas DynamoDB, you need not to do that. You just can do on the fly push button scaling. You just wanted to increase, you can just increase, go set it. Let's say read capacity is 10. Save. Provision capacity is updating. It's updating even here. And you also have reserved capacity. So you can go with that reserved things. Let it go update. It will take some time to update. This is the dashboard. The provision read capacity is 5. That will change now. Let's go to the tables. It's updating. Once it is updated, you'll see the latest thing. Okay, meanwhile, we'll just go discuss something more. That's about Redshift and other things. And guys, yeah, the other meeting which we used to follow all these days has got expired. So please join into this meeting every day till we finish our course, maybe the rest of the classes. So in the DynamoDB, we have seen something, databases, RDS and DynamoDB practically. As I said, Redshift and Elastic Cache will be discussed theoretically. So try to understand any point you are missing, you can just ask me. So let's go and discuss something about Redshift here. As it is mentioned, fast, simple, cost-effective data warehousing. So what it is actually. So Amazon data warehousing service it is, and it is, as it is mentioned, fast and simple, but not only simple, it is powerful, very powerful. Fully managed petabyte scale data warehouse service in the cloud. You can have petabyte scalable database or data warehouse service in the cloud that can start small for 0.25 per hour and scale to a petabyte or more for $1,000 per terabyte per year. So this is what they charge for this data warehouse service. Okay, so for a small one, it will charge you $0.25, something about 25 cents. And if you wanted a very large one, they'll charge you $1,000 per terabyte, 1 terabyte database or data warehouse service for 1 year. So always anything in AWS will charge on two different things. One is the amount of time you use and the service type of service you are using. So every service will have different pricing and different amount of time you use. It will change. That may be some services may be charged for per month, some services may charge you for per an hour, and some services, of course, like this charges per an year. And configuration, it can be configured on a single node, can have 160 gigabytes of data. When needed to scale, need to go for multi-node only. When you go with multi-node, you'll have two different nodes in that. One is leader node. Okay, it's like clustering concept. You have heard anything about clustering, guys? Have you? Anybody?
Yes, sir.
Yeah, clustering is nothing but what? It is a high availability environment. One node goes down. It's nothing but
If one is go down, another one backup. It's
yeah,
just like backup.
the one will perform your work. So that is what. So here also we'll have to go with multi-node when we wanted a larger scale is needed. So that in that we'll have leader node and compute node. These are the two different nodes we'll have. One is leader node. Let's understand what it is. The leader node manages client connections and receives queries, and compute node stores data and performs queries and computations. With this multi-node, we can have up to 128 compute nodes. Okay, up to 128 compute nodes we can have. With that, it can faster. You can imagine how fast it performs the things. So that is what we were talking, and it is just 10 times faster with columnar data storage. And instead of storing data as a service of rows, Amazon Redshift organizes data by columns here. So that's what it is. I just said 10 times faster with columnar data storage. It always stores the data in terms of columns, not in terms of rows. With that, the fastness of the data increases. Then columns-based system required for IOs, fewer IOs, greatly improving query performances. With this columnar, storage, we can go increase the database performance really very high. That's one thing. And then we also have compressions here for storing the data. That's what compressions, advanced compressions. So columnar data stores can be compressed much more than row-based data stores because similar data stored sequentially on a disk. Something which is similar can be stored. Let's check whether our thing is updated. Yeah, it's updated, active. Let's go to the table and see its capacity. It's 10 and it's 5. That is the best thing. Insufficient data. Alarm set is okay. With capacity, write capacity. Because we're not writing anything, so it's insufficient data, and read capacity, it's okay, fine. So this is how you can just do something or play with this. Now I think we're done with this, so I'll just go delete it. Here you see the read capacity has changed to 10 and it is 5. I'll go to actions, import. You wanted to import some data into this export, you can just do some exportation from this. Unit is nothing but what the amount of time you know or read or amount of time you write into this data, not the data into the database. That is calculated always in terms of units. Okay, and I'm going to delete it. So just remember how to create a Dynamo table and creating items into that, and also increase or decrease or alter its capacity, the read write capacities, and that is always measured in terms of units. So don't get confused. Don't worry anything about it. Then so we are talking about advanced compression of this Redshift data warehouse. So as we just discussed, it always compress much more than a row-based data storage because similar data is stored, and employ multiple compression techniques can achieve significant compressions. So we can have multiple different type of compression types. So using that we can compress the data. Why do we have to compress the data? Can somebody? Yeah.
To use less space.
Yeah, to store more data in a less space, we compress. That's in generally we do, like using WinRAR and all, right? Zip, zip everything and keep. So in a less storage, we can keep more amount of data. That is what. So here in Amazon, everything is charged and mainly charged for storage, storing the data, the amount of data we store. So in order to reduce our pricing, we compress our data. Then that's a little about this one, Redshift. And when it is about pricing, it is, as we discussed, charged compute nodes per hour and not charged per leader nodes hour basis. We only charge for compute nodes here. So you can just make a note of this. Always when it is a multi-node, a Redshift with multi-node is created, as we discussed, there are two different nodes, leader node and multi-node. The leader node is not charged because it just manages the client connections and receives queries. But what's actually executing the compute node? Compute node, store data, perform queries and computations. So compute nodes are charged per hour basis. Okay, and data transfer also charged only within the VPC, not outside it. The data transfers can be done within the VPC only. And we also have the option of encryption as security. So encrypted in a transit using SSLs, like how we have discussed about encryption in terms of S3 bucket. The same way, encryption in transit with SSL certificates. Encryption can also be done at rest using AES Advanced Encryption Service, AES-256. That's the encryption method. Or by default, Redshift take care of all the key managements. Okay, you can also do that by you can manage your own keys to hardware security modules, HSM we say, and AWS key management service. It is also possible with that. Now actually this Redshift availability, when we need to check, it is currently available only in one AZ. Now at the moment, the Redshift is not defined or designed for multi-AZs. You can store or you can restore snapshots to a new availability zone in the event of an outage. Okay, if something goes down, since we do not have Redshift designed for multi-AZs, what we can do if that respective availability zone not reachable or not responding or goes down. What we can do is we can restore the snapshots to the new availability zone and can create our Redshift data warehousing database again. So that is another point you have to remember, guys. You clear with that? So that is all about I wanted to discuss with respect to Redshift. And now let's discuss a little about Elastic Cache. And after once that is done, we can just say that this is done. The Redshift, like the database is done. 8:28. I think you guys have got time, right? So there are 2 points I need to discuss. Let me discuss and complete probably by 9 o'clock or maybe lesser than that if it is possible. Now Elastic Cache. See, Elastic Cache, it is mentioned in memory cache. Now just tell me what about cache? We have just discussed something about caches in terms of where Cloudfront. You remember anything? What is Cloudfront? What for it is used?
It holds the cache of some data,
Okay. So what?
and every time it will help us no latency.
Yes. When we wanted to access our data with less latency and faster as possible, or load our data without any delay, then the CloudFront is used. And what CloudFront does, it just stores the cache of entire data from its original location to an available edge location. So from that region, every time we access, it won't directly go to the original location, but it will go to the edge location. From the cache stored, it will get the data so that it loads faster as possible. So the same thing happens with respect to your database, and that's possible here with Elastic Cache. Okay, so in-memory cache. So with respect to this, it is, let's try to, now I hope you got an idea what is Elastic Cache is. So to understand it clearly, Elastic Cache is a web service that makes easy to deploy, operate, and scale an in-memory cache in the cloud. So the cache is stored in the cloud, not in any edge location. So the edge location concept is only for S3 buckets or EC2 instances or any data that can be accessed over internet, over a network. So database is something different. Databases are always created for one particular organization and to have all their data stored in that. So probably we won't provide the access to the databases to somebody. So that's why another cache system is created for that. That's Elastic Cache. So in the cloud, the cache is stored with respect to that. It makes us easy to perform, deploy, and operate our databases. Then it improves the performance of web applications by allowing us to retrieve information from fast managed in-memory caches. It not only makes us makes our work easy to deploy and operate our databases, but it also improves the performance of applications, web applications, by allowing to retrieve information from the fast managed in-memory caches. And Elastic Cache is also used to significantly improve latency and throughput for many heavy application workloads. So social networking, gaming, media sharing, or streaming, whatever you wanted, you can just say that. And Q&A portals, question and answer. You just post a question and you should get an answer in time, just in time, like without any delay. So for all these kind of things, Elastic Cache is best suitable. Okay, that's the point. Then what else? Elastic Cache. Okay, it also improves application performance by storing critical pieces of data in memory. It won't. It need not to store entire data into it. But what's important for that? So that pieces are that bits and pieces of the data into the memory, and will be able to improve the performance of the applications with less latency access. So as we discussed, the types of caches are, we already you guys already know that the same two types are discussed even here also. That's memcached, a widely adopted memory object caching, and the other one is Redis, that is a popular open source in-memory key value store that supports data structure such as stored sets and lists. So it supports master or slave replication and multi-AJ, which can use to achieve cross-AJ redundancy. The is used even for cross availability zone redundancy also. Okay. So these are the two different type of cache services we have, and Elastic Cache is a good choice if your database is particularly read heavy and not prone to frequency changing. Can write the to cache? No, you have to decide which cache engine you wanted to take. Okay, so it always depends which cache engine you're using and what is your requirement. So the other point what we are talking about is Elastic Cache is a good choice if your database is particularly read heavy and not prone to frequency changing. So you wanted your databases to be accessed maximum, then Elastic Cache is the best useful, because when people are trying to access many a number of times, automatically its cache is stored, and people will be able to access faster. And Redshift is a good choice. Elastic Cache and Redshift, you see. Elastic Cache is a good choice if your database is particularly read heavy. And Redshift is a good choice if the reason your database is feeling stress is because management keeps running online analytical programming transactions onto it. Okay, OLAP, online analytical programming transactions, are mostly done, then Redshift is a good choice. If it is a database is read heavy, then Elastic Cache is a good choice. Okay, so that is all about Elastic Cache. Hope you guys could understand something. Do you? Anything you wanted to clarify? Yeah. Okay. Apart from this, okay, if you go to RDS, let me discuss even this so that we can fully complete our databases and try to launch an instance. You have something called Amazon Aurora, remember? So this Aurora service is actually recently introduced into Amazon. Of course, this may be outdated now. Tables, of course, we don't create tables in RDS. We just create the database and provide them. So people who want it, the database engineers, they create the tables using writing queries. That the other day when we have created an RDS instance, we have just written some code or queries that connected to PHP, connected.php script is written, right? So using that connected.php, we are actually creating a database and able to connect to that database using that EC2 instance. After once you are able to connect it to your database instance, there you can just do whatever you wanted. Are you clear?
Clear.
Okay. So Aurora, that's what we are talking about. So in reinvent is nothing but it is a program what Amazon always conduct. Um, so every time they are coming up with a new service, Amazon people, they actually conduct a reinvent program. Maybe every year in the month of December or every alternate year, probably every year in the month of December it is conducted. So in the year 2014, Reinvent, they have introduced this Amazon Aurora service. So what is this? It is actually a database engine in RDS, Amazon, and it is actually MySQL compatible RDS engine that combines speed and availability of high-end commercial databases. Speed and availability with simplicity and cost effectiveness of open source databases. Not only speed and availability, but also simplicity and cost effectiveness of open source databases. Provides up to 5 times better performance than MySQL database at a price point of 1/10 of the commercial database while delivering similar performance and availability. Let's see here, it is written. Select, see here. Recommended Amazon Aurora. This is recommended. MySQL compatible enterprise class database at 1/10 of the cost of commercial databases. So Amazon by itself suggests you what is the best they have and what you wanted. So that is another good thing about Amazon people. Okay, that is what. And Amazon Aurora scaling. Okay, so that it starts with 10 gigabytes of database and can scale up to 10 gigabytes increments every time you want it to increase to up to 64 terabytes. It's like, one time you want it to increase, you can always increase minimum of 10 gigabytes, not 1 2 3 like that. So every time it's a multiple of 10 gigabytes you will be able to increase, and in that way you can go up to 64 terabytes of storage auto scaling. You wanted, you can just increase. You don't want, you can just decrease the scaling. So that is the performance and cost effectiveness comes into picture. So that is what scaling is. And compute resources can scale up to 32 vCPUs and 244 gigabytes of memory. You remember when we are trying to create an EC2 instance, we had a memory optimized instances with 36 gigabytes of 36 vCPUs and 244 gigabytes of memory. That's nothing but RAM in terms, not ROM. So the same thing is here also, because of this high-end compute resource, you can just perform the databases perform very faster. And scaling is done in a maintenance window, of course, not like push button scaling, but will be done in a minute times, faster, very faster you can just perform. It's not like that a normal RDS instance that you have to take couple of hours time, but it can take, it can be done in as less as time possible, maybe in a minutes of time. So this is another best thing. You don't need to, make your clients wait a longer time. Within the less time, you can just complete your, activity, and then you can bring your database up so that people will be able to access. And you will have updated database in terms of configurations, in terms of capacity and all. And always it maintains 2 copies of your data, okay, contained in each availability zone with minimum of 3 availability zones. Okay, so 2 copies I'm saying and 3 availability zones I'm saying, which means every availability zone it stores 2 copies of data. So if it is 3 availability zones, so it's nothing but you can go up to 3 availability zones, the extension. And if you expand your database to 3 availability zones, 2 in each, so it will have 6 copies of your data. So see how redundant your data is. It is so safe that you need not to worry anything about your data. And it is designed to handle the loss of up to 2 copies of data without affecting database. Even if you lose your database data for 2 times, you'll still be able to, get it back. That is how it is designed. And write availability. Okay, in terms of data, it is 2 copies, but write availability and in terms of 2 times and up to 3 copies without affecting read availability. When you're trying to write up to 2 times, you lose, you will be able to get. And read availability, even if you lose for 3 times, you will be able to get and read your data without any problem. So that is what another important or the best thing about it. Then Aurora storage is also self-healing. That's nothing but data blocks and disks are continuously scanned for errors and repairs automatically. So if there is something wrong, you don't need to worry anything about it. The database by itself scan every time once it is created, and if there are any disk blocks left like that, so those disk blocks are filled, and if there is any error or if there is something corrupted in between, so that will try to repair by itself without your intervention. So that is another advantage with this Amazon Aurora. So this is the best thing. When you wanted to create a database, there are many possible uses with this Amazon Aurora. So just have an idea about it. Um, don't need to worry anything about, because we are not truly database guys. And we usually don't create any databases. We provide the instances with PHP installed into it. So that probably uh, we usually do. And Aurora replicas. It will always have two types of replications available. One is Aurora replica that can have up to 15 replicas, whereas we discussed something about RDS replicas, that MySQL read replicas, they will have only 5 replicas. I think you remember we discussed that every database can have 5 replicas of it, the maximum of, and replicas can also have replicas. That's what we have discussed. But here, Aurora replicas, by itself it is giving you maximum amount of 15 replicas. So how faster your read capacity can be increased. The access will become very faster with this. You clear with this point? And if primary database go down, automatically failover happens to Aurora replica but not MySQL replica. We ourselves have to go and then do something with that, but in Amazon Aurora, the failover automatically happens. So that is another best part about this Amazon Aurora. And Amazon instances replicas are not part of free tier. That's why we are not going to do anything. Okay. And I'll just tell you one thing, guys. If you are really greedy in learning and wanted to explore yourself in all the maximum ways, there is one possibility. Okay. I'm not telling you to try, but if you are really very greedy, you can have this possibility that if you try something nasty and charged unnecessarily, and if you don't want it to pay, you can always reach out to the Amazon support people saying that you are learning it. So unfortunately, the mistake has happened, and you could not close down something or could not delete something, so that you are charged for that. If you request them, okay, Amazon people will waive off your bills up to certain limit. The minimum amounts, something like $10 or $50, something like that, or maybe in Indian currency, 3,000, 5,000, something like that. So they waive off such amounts, but before they waive off, you should delete or terminate every service you have in your account that is charged or not charged, part of free tier or not, anything it is. But be careful when you try that. Don't go for high-end things and unnecessarily pay. Okay, so this Aurora is not part of free tier, and we don't have T2 micro instances in it. The only thing we have in this is, if you just go select it, it is only supported for only these type of instances only, not the other type, because it is memory optimized and faster performance. When it needs to perform very faster, it obviously should have maximum amount of capacity. That's 2 VCPs. The maximum is what? 32 vCPUs and 244 gigabytes of RAM. That is what we have discussed. And always DBR3 instances only eligible for this. We can have as many as failover as edges in a region. So you have 3 availability zones. You can have 3 failovers with this Aurora. So that is another thing. So this is all about Aurora, guys. I hope that could really make sense what and how best Amazon Aurora is. So with this, we have completed our database totally. Okay. I think Shilpa is waiting to leave. So we finally done with our database. So what else we are left with? Tomorrow we'll begin our class. We'll discuss something about VPC. So database is done, and S3 EC2 database totally done, completed. In networking we are done with 253. So we will be going through VPC tomorrow. Once VPC is done, for you guys, Anu, Rajita and Sai, for you guys, I have to discuss identity and access management. The rest of the guys, if you are interested, you want it, you can join, but you already have your videos and the same trainer is, discussing this, so there may not be much difference in that, but it's up to you whether you wanted to have these classes or not. But after once VPC is done, we'll go with SNS, SQS, SWF. In the end, I'll go with IAM. Okay, so tomorrow we'll complete VPC, then day after we'll complete SNS, SQS, SWS. That's day after is what, Thursday. So probably by this Saturday we may end up the sessions. Okay, guys.
What is DMS?
DNS Route 53 domain name service. You forgot,
In
Sai?
database, there is a in database there is a last one like DMS. That is and
The DNS link is always used to connect it to the database here. Like an
okay.
endpoint. Like an endpoint when we created a database in RDS instance. How do somebody connect the database and then put their data into that? So that it always needs to have an authentication or an access. So that access is provided with this DNS name.
Okay, domain service. Okay.
Yes, yes. All the everything will be created with a DNS in this in Amazon. Like ELB has a DNS. Unless if it is an EC2 instance. EC2 instance will only have EC2 instance will also have a DNS, public DNS name. You remember IP address, the combination of public
Yeah,
IP
yeah,
and the long list. So everything, every
yeah.
service you create in this Amazon will have a DNS name by default.
I
And
mean, in database we have DMS, database migration services.
database migration service. When you wanted to migrate your databases from one to another, then the DMS service is used. Okay. Anything else you wanted to clarify here?
So like today in one requirement I saw the cloud managing IaaS and PaaS, SaaS. What are those, sir?
IaaS.
Yeah, AWS, PaaS, SaaS.
I think we discussed that in the very first class. You remember? The very first
IOPS.
class. The very first class. Yeah, this is what you're talking about, right, Sai?
Yeah.
See, we have discussed this in the very first class, the demo class or anything, but I'll still discuss this again since you asked me. I Let's
Okay.
come from bottom to top. SaaS is what we simply say SaaS.